Hello YouTube, today we're going to be learning about right triangle trigonometry. So to start with, a right triangle is a triangle that has a right angle, and we indicate it with this box. A right angle is an angle whose measure is 90 degrees. Now, a theorem that you guys probably learned about a while back in 8th grade dealing with right triangles is the Pythagorean theorem. And what does that say? That says if you square the legs and sum them together, it will equal the hypotenuse squared. Or as you guys probably know it, a squared plus b squared is equal to c squared. And we have to remember the hypotenuse is always the side opposite that right angle. And therefore the leg will be here and the leg will be here. So we're going to be learning about other ways that we can solve right triangles dealing with the angles and the sides. So a lot of times we measure the angle using the variable theta. And based off this, there is sine, cosine, and tangent that we can use as ratios in order to solve for a missing angle or missing sides. So what are they? Sine of an angle is equal to opposite over the hypotenuse. And by opposite, we mean the side opposite the angle theta, and the hypotenuse is always the side opposite the 90-degree angle or the right angle. Another trig ratio is cosine. Cosine is equal to the adjacent side over the hypotenuse. The adjacent side contains a ray that forms that angle theta. And again, the hypotenuse is again the side opposite the right angle. And the last trig ratio we're going to be learning about today is tangent. Tangent is equal to the opposite side over the adjacent side. Now I'm going to go ahead and label these in my picture. So again, we said this was the hypotenuse, opposite the right angle, the adjacent, which is one of the rays that forms the angle theta, and opposite, the side that's opposite the angle theta. So while we do have these three trig ratios, there are three more trig ratios, but we won't be learning about them today. So where do these ratios come from? If I create a larger right triangle and create a similar triangle, then this is where the trig ratios come from. So let's go and label our hypotenuse, our opposite, and our adjacent side in this figure. I'm going to label the hypotenuse of the smaller right triangle A, the hypotenuse of the larger right triangle as B, the adjacent of the smaller triangle as C, the adjacent of the bigger right triangle D, the opposite of a smaller right triangle E, and the opposite of the larger right triangle F. So where the sine ratio comes from is that the opposite of the smaller triangle is E, the hypotenuse of the smaller triangle is A. And this ratio will be equal to the opposite of the larger right triangle, which is F, over the hypotenuse of the larger right triangle, B. Similarly, for cosine, the adjacent of the smaller right triangle is C. The hypotenuse of the smaller right triangle is A. Now for my second triangle, I'm going to do a similar procedure. This angle given is 29, so I'm going to go ahead and label my three sides as opposite, adjacent, or hypotenuse. Well, I know my hypotenuse is opposite the 90-degree angle and has a value of 7. The side opposite 29 is here, which I'm going to label as Y. And last but not least, this last side is the adjacent side, as one of the rays forms the angle 29. So again, if I want to solve for x, I'm going to use my value that I know, my hypotenuse, and then I'll have to use the adjacent. So the ratio that uses the adjacent hypotenuse is cosine. So I'm going to take cosine of my given angle 29 and have that equal my adjacent side, which is x, over my hypotenuse 7. Now again, I want to solve for x, so I'm going to multiply both sides of my equation by 7 to get 7 times cosine of 29 degrees equal to x. And again, I'm going to plug this into my calculator. 7 times the cosine of 29. Again, I'm going to round to 2 decimal places, but depending on the directions, do what it says. So we have 6.12 is equal to x. So again, this is what I just solved for x. So I'm going to say x is equal to 6.12. If you start comparing this last example to my previous ones, you would see that we started with a given angle, one given side, and a missing side. But now this problem's different because I know 2 sides, but I don't know what my missing angle is. So I'm still going to set up my ratio the same way. We're just going to have to do one extra step. So again, in accordance to theta, the opposite is going to be my value 6. The side opposite the 90 degrees is my hypotenuse. And my last remaining side is my adjacent, as the leg forms one of the rays in that angle. And again, I know my hypotenuse has a value of 11 and my opposite has a value of 6. So I go over here. Opposite and hypotenuse requires the ratio sine. So I have sine of my angle theta is equal to my opposite 6 over 11. Now the issue is we can't just divide both sides by sine because you have to take the sine of something. But what we can do to both sides in order to isolate the angle theta is take the sine inverse of both sides. And what this does is sine inverse and sine cancel each other out, so we're just left with theta is equal to sine inverse of 6 over 11. And then if you notice in your calculator, usually in blue depending on the calculator have, if you hit second sine, it gives you inverse functions. So I'm going to type in inverse sine, 6 divided by 11, close my parentheses, hit enter, and I get that theta is about 33.06 degrees. And again, it's really important that your calculator is in degree mode for this problem since it asks for degrees. So I'm going to fill in theta equaling 33.06. Do you have any questions? Yes?
Do we get extra credit for visiting the Learning Center?
No, but you should visit anyway. Subscribe to us for more content.